Hello, Matthews, Gatos here. Welcome to Mixed and Entire Radicals. Before I jump into radicals, let's talk about something you're all familiar with, which is fractions. Let's talk about simplifying a fraction. To simplify a fraction, you just find the greatest common factor of the numerator and denominator and divide each by it. So for example, 14 over 36, the greatest common factor would be 2. So I divide the numerator and the denominator, to be fair, by 2, and I get 7 over 18 in lowest terms. Now, 14 out of 36 and 7 out of 18 look different, but when I punch them into the calculator, they both have a value of 0.38 repeating. So simplifying a fraction doesn't change the value, it just looks different. So when I simplify fractions, I know that they are fully simplified when the greatest common factor of the numerator and denominator is 1. Radicals, however, are simplified when there's no more perfect factors under the root. So as an example, square root of 24 is not simplified because it has this perfect factor of 4. So I know that root 24 simplifies as 2 root 6. I'll show you how that works in a minute. But what I want to point out is that the square root of 24 and 2 root 6 look different, but they actually have the same value, which is approximately 4.9. So the value doesn't change when I simplify. So before I get into simplifying, let's just get a couple pieces of terminology under our belt. So in this example here, I have square root of 24 and cube root of 24. Now, how did I know one was square root and the other was cube root? Well, that has to do with this index, this number in front. I knew that was a cube root. Now, notice the square root doesn't have a number there. I like to think of it as an imaginary 2. So if there's no number there, I know it's the square root. Now, both of these numbers have a number entirely under the root sign, and that number is called the radicand. So that's what's underneath. When you put together the index, the root, and the radicand, the whole thing all together is really cool. So cool, in fact, you could call it radical. Last piece of terminology I want to cover is entire versus mixed radicals. Now, entire radicals, exactly as it sounds, are numbers or roots where the radicand is entirely under the root. The number is entirely under the root. A mixed radical is a mixture of an integer and a root. So what we're going to be doing in this video is looking at how do I go from entire to mixed radicals, and how do I go from mixed to entire radicals. Let's get started with entire to mixed, also called simplifying. So I want you to identify the index. Am I taking the square root or the cube root, etc.? Then look for highest perfect factors. So square root, I look for highest perfect square factors. Cube root, I look for highest perfect cube factors. And then I'm going to write the radicand as a new product. It's going to be the product of the perfect and the non-perfect factors. I'm going to evaluate the square root of the perfect factors multiplied by the square root of the non-perfect factors, whatever's left over. And of course, I'm going to check on the calculator. So let's get started with our first example. If I want to evaluate the square root of 75, in my last video, I showed you guys how to generate perfect squares on your calculator. So here are the first 10 perfect squares. I want to find the highest perfect square factor. I know it's not going to be any higher than the number itself, which is 75. So you could almost work backwards if you wanted to. So 64 doesn't work, 49 doesn't work, 36 doesn't work, 25 works. That would be the highest perfect square factor. So I'm going to write root 75 as the product of the perfect factor 25 and then multiplied by the leftovers. Now, how do I figure out the leftovers? Well, 25 times 3 is 75. So 3 would be the non-perfect factors. Now, the square root of 25 is 5, and I will multiply that by the square root of 3. So what that means is that 75, root 75, in lowest terms will be 5 root 3. Notice I got rid of the multiplication symbol. I don't need it anymore. I'll just write it as 5 root 3. Now I like to check that on the calculator, and I can see that root 75 and 5 root 3, they look different, but they have the same value, so I know I did that correctly. I'm going to show you cube root, but we haven't done too many cube roots on the calculator, so let's review how to do that. So square roots, we know how to do square roots. That's just second and then your exponent, your squared key. To do other roots, any other root other than square root, you're going to go into your math button, and then you're going to use option number 4 if you're doing a cube root. So option number 4 would be cube root of whatever number you're interested in. Now sometimes we want something other than square root and cube root. So then we're going to go to our general root. So our general root, math, option number 5. See how there's an X there? That X can be any number, but you have to tell the calculator what number it is. So you have to enter the index of the root first and then go into this option. So for example, if I wanted to do the 4th root, I would hit number 4 first, then I would go into my math button, and then I would go to option number 5, which is my general root. And on the calculator screen, you'll see that I have the 4th root, and then you can fill it in. Okay, let's try cube root. So cube root of 128. Again, I'm going to generate my perfect cubes on my graphing calculator and pull them up here. There are the first 10 perfect cubes. So again, if I'm looking at 128, it won't be any higher of a number than 128. So I'm going to look at there and below, and I'm going to work backwards. So I'm going to look for the highest number that goes into 128. So it's not 125, it is 64. Now the reason I like to go backwards is because look here, 8 is a perfect cube factor, but it's not the highest perfect cube factor. So I like to work backwards in my table. So I'm going to write this as the cube root of 128. That's the same as my perfect factor of 64 multiplied by my non-perfect factor. Well, I know that 64 multiplied by 2 gives me 128. So those are my non-perfect factors. So cube root of 64 I know is 4, so that will be 4 times the cube root of 2. So I know the cube root of 128 simplifies to be 4 times the cube root of 2. Now, I remove my multiplication symbol, but notice I put it in brackets. So I put it in brackets because I want everyone to know that is the cube root of 2. Sometimes, I know my writing can get a little messy, and I wouldn't want someone to think I was talking about 4 cubed multiplied by the square root of 2 if they're too squished together. Or it would be really bad if they thought it was the 43rd root of 2. So I don't want any of those mistakes to happen. So I will always put my roots other than square root in brackets. So let's check to see if that's right. Is the cube root of 128 the same as 4 cube root 2? You can see even though they look different, they do have the same value. Okay, let's go on to mixed to entire radicals. So to do this, I want you to identify the index first. What kind of a root are you taking? And then take whatever term you have outside, raise to the exponent of that index, and write it under the radical. Then you're going to multiply that with what's already underneath the radical. Now this is really important. If the root started as positive, it stays positive. If the root started negative, it stays negative. You don't change signs. So you don't change signs just because you're changing the form. So a mixed to entire radical that's positive stays positive. A mixed to entire radical that started negative stays negative. And last step, always check on your calculator. So let's try 2 examples again. So I have 5 square root 2. I want to write that, 15 square root 2. I want to write that as an entire radical. So I know my index is 2. So to put it under there, I'm going to take my number on the outside and raise it to the power of the index, which is 15 squared. That just means 15 times 15, which is 225. So then I will take the 225 and multiply it by what's already under there, which is a 2. So 225 times 2 is 450. So that means that 15 root 2 is the same as the entire radical square root of 450. Now I always like to check that on the calculator, and you can see even though they look different, they do have the same numeric value, so I know I did that correctly. Okay, next one. I have -2 cube root of 5. So -2 cube root of 5. So I identify the index, which is a 3. So to put the 2 underneath there, I'm going to raise it to that index. I'm going to do 2 cubed, which is 2 times 2 times 2, which is really just 8. Leave my negative on the outside. So it's going to be negative the cube root of 8 times 5. So that tells me that -2 cube root 5 is the same as negative the cube root of 40. Now let's check that on our calculator to see if that's right. And you can see, even though they do look different, they do in fact have the same value. So I just want to end this lesson by saying math is radical. Now I have no idea where I found that. I found that such a long time ago. It was obviously an advertisement. I would love it if someone could find me those buttons. If you do, let me know because I would love to purchase a 10-pack. Heck, I'd even purchase a 20-pack. So if you liked this video, please give it a thumbs up and hit subscribe. It helps me reach more mathies in need of help. Thanks, and see you for the next one.